Alright, here's number 4. Writing solutions of an inequality using interval notation. So unlike previous example, we write solution in set notation where you're using the braces, okay, m such that m something. The previous example we have is m greater than -3. This is the set notation, okay. Now, for this part, number 4, we write the solution using the interval notation. So here there are 9 cases. Interval notations involve parentheses, okay, or brackets, or any combination of these two. That's why we have 9 cases here. Both parentheses, where x is any real number between these two endpoints, A and B. A, B are endpoints. Again, if we use parentheses, it means we don't include the endpoints A, B. Okay, this is the graph. This is the interval notation. This is the set notation. And this is the graph of the inequality on the number line. Okay, case 1. Case 2, endpoints A, B are included. So we use the brackets right here. It means x is any real number between the two endpoints A and B. Okay? And here the graph we have is both brackets here, including A and B endpoints. So the solutions are any real number between the two endpoints. Case 3, we have the left hand side is the bracket, so we include this endpoint A, and the right hand side parentheses, so we don't include the endpoint B. So the solutions are any real number x such that the solutions are between the endpoint A, including it, and B, but not including the endpoint B. So here the graph, left A bracket, right B parentheses. Solutions are any real numbers between A and B. Okay. Case 4, we have left hands. The left is parentheses, so we don't include A. Right is bracket, so we include B. Solutions are any real number between A and B, but we don't include A. Case 5. Now, for case 5, we use the special symbol infinity. Infinity means the solution extends without bound. So, for this case, we have x is any real number such that x is greater than a constant A. So, the interval notation will use a comma infinity, set notation here, and here the graph on the number line, so we don't include A. Solutions are any real number from A on without bound. It's extending without bound. Okay. Case 6, similar to case 5, with the exception is that we include the left hand side 8 right here. So solutions are from A extend to infinity without bound. But we count 0.8, the left endpoint. Case 7, we use negative infinity, meaning, again, solution extend without bound, but to the left, to the negative side. So in the interval notation, we use negative infinity, and then comma B. For set notation, we say x such that x less than B. On the number line, we have from B to the left. So solutions are any real numbers that from B on but extend to the left, negative side. But we don't include the right endpoint B. Case 8, very similar to case 7, very similar, except that we include the endpoint B. Okay? For case 9, it's the case that solutions are any real numbers. Okay, we don't exclude any numbers. So for interval notation, we'll have negative infinity to infinity. In set notation, we have x such that x is any real numbers. Okay. So here's the graph. Do you see that on the number line, there's no exclusion? We include all number on this number line. Okay. So I have the example here. Write interval notations for the given set. Okay, this is the set notation for the. We have t such that t is between -10 and 10. Notice that the left endpoint we use less than, meaning we don't include this left hand side. So exclude -10. But the right hand side, we use less than or equal to. I mean we include 10. Okay? So we're going to write this set notation to interval notation. Again, interval notations are any combinations of case 1 to case 9 using parentheses and bracket. Okay. So for this case, we know that we exclude -10, but include 10. Solution. So let's see. Solution. So solutions are any real number between, right? If it's between, so which case are that between? So from case 1 to case 4, right? Do you see that? Case 1 to case 4? It has similar expression between. So which case is that? You see it matched between case 1 and 4. This is less than, greater than equal to. So it has to be case 4, right? So the interval notation, we exclude left-hand points, include right-hand point, and solutions are between the two endpoints. So it's going to be left parenthesis, left-hand point -10, and right end point is 10, and we including it. Okay, so this is the solution. All right. So by the way, for these 9 cases, you can find it in my notes. For the summary table, it's on page 5. Okay, this is on page 5. But you can find everything from page 2 to page 5. Okay. So I have another example. Similar question, just different set notation. So I'm going to erase this. Okay. So the set notation is t such that t is greater than or equal to -5. Okay. So again, write the solution in interval notation. So which case is that? One of the 9 that has similar form like this. All right, we know that it's not going to be the first 4, right? Because the first 4 are any solution between the left endpoint and the right endpoint. So let's see, 5 to 9. Now, let's see, 5 to 9, which one is that? Greater than, okay. This is last we don't include, so greater than. So look like it's going to be case 5 and 6. 5 and 6 because greater than. So, but it is greater than or equal to. So it's got to be case 6. Are you with me? It could be case 6. So interval notation is going to be like this, okay, including the left endpoint and extend with down bound to the right. That's why it's infinity right here. going to be this. Okay, case 6, which is -5. We're including it, and it extend without bound. Now, for infinity, because it's not a finite value, right? Infinity means any number, any positive number that's extend to the right. So because we don't know what a finite number, we use parentheses. We don't use brackets for infinity. For positive infinity, we use right parentheses. Okay, so this is the answer. And I have another example which has the same question with a different set notation. Okay, for this one, a little bit different. Apologize for that. Saying right interval notation for the given graph. So, this case, we're given the graph. Find the interval notation. Okay, the previous two examples, given set notation, write the interval notation. Okay, for this example, you'll be given the graph, the number line. Find the interval notation. So here I have the graph. 8 brackets extending to the left, okay, without bound. When you see an arrow pointing as one direction and extend without bound, it's going to be either positive or negative infinity. Okay, for this case, because it's extending to the left, it's going to be something with negative infinity. Okay, so let's see. We know that it's going to be k. Which k is that has this graph? Brackets to the left. Now, as you know, there's that not case 1 to 4. There's no infinity in here. Okay, and it's not extend without bound. Let's see, 5. Not this one because extend to the right. Not these. Look like these two. Which one is that? Brackets. So actually, it's case 8. Okay, case 8. Right endpoints is 8. Extend to the left. So the interval notation is something like this, case 8, which is negative infinity to something, which is this case 8, right endpoint. Now again, for infinity, it's not a finite number, okay? So we don't know what number it is. We're going to use parentheses. For negative infinity, we use left parentheses, okay? So the answer is this.